This lesson is for Advanced Algebra, Lesson 7-6 on nth roots. I want to help students right away with figuring out what an nth root is. So first I'm going to give you my definition. A root is just the inverse of taking the power or taking an exponent. Here's the book's definition. Let n be an integer greater than 1. So we're only going to be talking about numbers bigger than 1 here. Then b is an nth root of x if and only if b to the n equals x. So the n is the root and the x is the answer that we're trying to find. So here's some just real basic root problems that students may or may not already know how to do. If you're taking the square root of 9, most kids will probably think about it with the radical symbol. And algebraically, I want you to think about it as a formula like this. What number times itself equals 9? And so most students I know probably know the answer there, and they're going to say positive and negative 3. We'll talk about why there's going to be positive and negative at the end of the lesson today, so if you're not sure why there's supposed to be two answers, just wait and see here on the lesson. We're also going to get into other types of roots today, not just square roots. So another one that students may be aware of is a cube root. Most students are probably used to doing the radical symbol with a little 3. So there's a 3 there, and then the radical symbol, and then your number 8. Again, keep in mind that using a formula here, or an equation, you'd say x to the third power equals 8. And so we're trying to find what times itself 3 times is 8. Hopefully students know that that would simply be a positive 2 there. If you did a negative 2, you'd end up with a negative 8 because it's an odd power. We're going to get into some other types of questions today, but that's kind of the basics of where we're headed, is trying to find that number that gets you from one to the other. Now let's look at this next one here where we're trying to find a 12th root. Now a 12th root would technically be a radical that looks like that, and if we're trying to find that for the 2, we would have x to the 12th power equaling 2. So that would end up being 12 x's that would be multiplied together, which is quite a lot. And so I wouldn't allow students to have to figure that out on their own. This would have to be a graphing calculator question. The two above would have been baby calc questions, because students could figure those out without even using a calculator at all. On this question, students would have to be allowed to use a calculator here. And so we're going to learn today how to deal with that, because most students, I think, won't necessarily know how to find the 12th root radical symbol like that. That is available on your calculator, but I'm going to show you another way today. I'll just give you a hint or a heads up here. We're going to figure out how to type in 2 to the 1/12th power, and that'll give us our answer. So that's where we're headed today with our root problems. To help a little bit with root problems, I want students to do something next in their notebook on a separate page, and that's to make what I call the roots page. So let me show you what that looks like. When you're working with roots, especially roots that you're not as comfortable with, like cube roots, fourth roots, fifth roots, sixth roots, and so on, it might be kind of nice to have a lot of the roots available together here in one page or in one spot. So it's the roots page or the roots and power page, and what you'll see here is that we've got some of the square roots listed, some cube roots, fourth roots, fifth roots, all the way up to a couple of the sixth roots. Most students should probably try to plan on memorizing, I would say, probably all of the square roots if you haven't yet so far. Probably up to the fifth roots, or excuse me, the cube root of up to 125 here on this list. And then a minimum of the 2's and the 3's here for the 4th, 5th, and 6th roots. 2 and 3 come up so often when you're doing root problems that it's a good idea just to get those memorized. Now if you're not there yet, or if you're thinking that that's a little bit overwhelming, just know that you can reference this page when you're doing homework questions, and the more you look at it and the more you reference it, the easier these will become. So let's go back to the notes and get back to our solving. So once you start getting comfortable with using roots, now we're going to get into solving with roots. So let's do a quick review here on solving for x. If you were solving 2x equals 12 for x, most students I think would know that you do the inverse operation here, which is divide. And so when we do that, we get our answer there of plain old 6. When you're working with a power, however, though, most kids I think would say, well, I'm going to take the square root of both sides. What we're going to transition to today is working with a power to get rid of the exponent there. So we're using an exponent to get rid of the exponent rather than using the radical symbol. Just a quick review here on the radical symbol. If we have radical 12 here, you'd want to try to simplify that, and this is a skill students should be continuing to develop. You'd want to look for two numbers that multiply to make 12, one of those numbers that we know the square root of. 6 and 2 would not be a good choice here because we don't know the square root of 6 or 2, so 4 and 3 would be better options here. What's going to happen is the 4 and the 3 get their own radicals separately, and so then we know that the radical 4 here is going to make, I'm going to move up to the top here because I ran out of room, I'm going to get positive and negative 2 for a radical 4, and the radical 3 is just going to stay put. Notice how there we put a plus minus in front of a 2 there, because hopefully students know that the square root of 4 is both a positive and a negative number. So what we're going to transition to today is trying to get that answer by doing a fraction answer instead of using the radical symbol. So that's what we're going to learn how to do next. So when you're solving x to the n, rather than using a root, I want you to try to use, from now on, a reciprocal power. And here's what it looks like. You've got x to the n. To get the n to go away so that the x is isolated, we raise to the reciprocal power of whatever that number is. So we're going to raise to the 1 over n power. When we do that, we end up multiplying these two powers together, so we get n over n. N divided by itself is 1, which gets us the x alone. Then on this side, we've got 1 over n as the power, and we're going to be able to figure out what y to the 1 over n power is. And so here's how that is explained in the book. So if students were copying notes here, they'd want to make sure to copy the yellow box here. The next statement here is something that students don't need to copy. I just wanted to mention that we're doing non-negative numbers when you're working with a rational power. So let's see what these look like when we actually apply them. Notice how here it says round to the nearest thousandth. This would have to be a graphing calculator question. So as soon as they ask you to round, you know that you can use your calculator here. So we've got x to the 5th power, and we're trying to get to 77. We're trying to solve for x, or isolate the x. So rather than using a radical here, we're going to raise it to the 1/5 power. We want to use a reciprocal of whatever the power is. The reason for that is because now we get x to the 1st, which is what we're looking for. So then students can simply type in 77 to the 1/5 power, and they'll have their answer. When you do 77 to the 1/5 power, you get, and it's the same as you typing in 77 raised to the 1 divided by 5. When you do that, you get about 2.38396, and then the number keeps going. To round it to the thousandth, you go to the 4th digit, which in this case would be the 9. The 9 tells you to round the 3 up. So our final answer here is 2.384 if we round to the thousandth. The next question would be a baby calc question. So you have to solve x to the 3 equals 1,000. So again, let's employ our knowledge of what to do about the power. We're trying to get the 3 to go away, so we're going to raise to the 1 over 3 on both sides. 3 times 1 over 3 becomes a 1 for x, which is what we wanted. Now x is all by itself. And now we have to figure out a number times itself 3 times that equals 1,000. So it's like doing the cube root of 1,000. So let's write that. We're finding the cube root of 1,000. So we need a number times itself that equals that. Hopefully students know that either they know it, or with a little trial and error they could say that x equals 10. And so if students wanted to add that to the roots page, they could. So they could add here 10 to the 3 equals 1,000. So let's do one more here. A lot of times when you're asked to solve, there will be other things there besides the power. So in this case, we need to get rid of the 3 first. So we want to work on isolating the x. So isolate the x by dividing by 3 first. So we get x to the 4 equals 625. Now we can go ahead and raise to the 1/4 power on both sides. So try not to get too excited about raising to the power first. Get rid of anything else that's next to the x before you do that. So now you'd want to utilize your roots page, and you'd want to look for 4th roots. So 4th root of 625 is going to be the number 5. So if you didn't know that, hopefully you could do a little bit of trial and error there to figure it out. Another hint for you there is if the number you're trying to find ends in a 5, usually 5 is going to be the number that you're looking for. So again, what we're trying to find there is the fourth root of 625, which means a number times itself 4 times that equals that number. So what do roots look like on a graph, and how do we know when we have multiple answers? So here's some information that I took out of page 488 in your textbook. Here's the number of roots you should expect based on whether it's a positive or a negative, and whether it's an even or an odd. And then below that is the same information just in graphical form. So let's explain here. Obviously we've got an odd graph on the left and we've got an even graph on the right. So let's take a look at the table and the graphs as we go here. So on the odd graph, if you're trying to find a positive root, you're going to get one solution. So a positive answer, you're going to have one real solution when it's odd. And when it's an even graph on the right, if you have a positive number you're trying to find, you're going to get two solutions, both a positive and a negative there. So it's going to be 2 or 1 solution when you're dealing with a positive or anything above the x-axis. When you're working with a negative number and it's odd, you're going to get one answer. If you're dealing with a negative number and it's even, you're going to get no answer. Clearly that graph doesn't cross this line at all, so there would be no solution there. And then 0 is its own root. So if you're trying to find a root of a 0, your answer is always going to be 0. So that's it for the notes for today. I do have 2 more items for students just to make note of. The assignment today was starting with problems number 4, so we skipped problems 1, 2, and 3. However, those questions in the homework are about geometric sequences in music, which are real-life applications of roots and powers. So those are optional questions, and if students are interested in that, that is available reading in the lesson. Also, the book does ask you in some of the homework questions to use the solve command. Know that you will always be asked to solve by hand and never asked to use the solve command on a test or a quiz. If you want to use the solve command to check an answer, that's perfectly fine.